Hello, welcome to Ohm's Law Lab Part 2. So now what we're going to be doing is looking at the Part 2 where you are looking at resistance and then current and keeping your voltage the same. So it was recommended that you keep your voltage at like 9 volts or 12 volts. So, that's what you can do. So I'm going to go ahead and keep mine at 9. And then we're going to take a look at our resistance values. So you should have taken the resistance values, and from the resistance, right? So when you took your data, you changed this and then recorded the number of current from the ammeter. And what you should have found out was it created a graph that kind of looked like this. And on your x-axis, you had resistance, and on your y-axis, you had current. And so then this is showing an inverse relationship. So resistance and current have an inverse relationship, an inverse nonlinear relationship. Okay. And then next, what we're going to talk about is the mathematical relationship part, right? So for Desmos, you should have typed in y1 squiggle k over x1. And the algebra version of this is going to be y is equal to k over x. And if you remember from previous classes, k is our constant. Okay, and we're going to talk about what that constant means. Now, your lab equation, or our equation, okay, is going to be whatever the y value was, which is current, is equal to your number, and so I think mine was about 9, divided by resistance, which was our x value. Okay, and so if you remember, the thing that we kept constant was our voltage. Okay, and so that's how we know that the units for our constant would be volts. So then this translates into our physics equation. That would be current is equal to voltage divided by resistance, or I is equal to V over R. So this would be our equation that we come up with based on the information that was given to us. Okay, and so I know that my voltage was at 9 volts, and so this means that resistance and current have a non-linear inverse relationship. Okay, so that would be my claim. And then the evidence, so I just went through the evidence for Desmos, right? So it was y1 squiggle k over x1, and then the algebra equation was y is equal to k over x, and then the lab equation for myself was current was equal to 9 volts divided by resistance, which leads us to our equation of I is equal to V over R. All right, and then the same thing here. So when the x-axis, so remember to replace it with your own, increases or decreases, the y-axis is going to increase or decrease. So make sure to choose one. So choose increase or decrease. Okay. And so then we're going to have a Desmos graph here. And don't forget to include the context. So along with your Desmos graph, don't forget the table, the equation, trend line, all of that. Okay, so that's for part 2. Part 2, evidence. And now for our reasoning, once again, don't forget to write it in paragraph form. Explain how your evidence is connected to your claim. So we're going to talk about how your equation of current is equal to 9 volts divided by resistance. How does this show inverse? Okay, how does this show that as you increase the resistance, let me write this somewhere else. All right, so for this part, how are you going to show that current is equal to your constant of 9 volts divided by resistance? And you're going to show this as when you increase resistance, the current is actually decreasing. So show and explain the graph and equation. Okay, why does it make sense for the resistance to increase and then the current will decrease? So why does that make sense? That's what you should say in this portion. Okay, what does it mean for the charges? Right, so once again, why does it make sense for the resistance to increase and the current to decrease in this situation? Okay, and so then as the same thing, explain each of these points. All right, and so that is Ohm's Law Lab Part 2.